Hey everyone and welcome back. We're diving into something pretty complex this time. Oracle CPQ's BOM mapping rules.
Ooh, yeah, it gets pretty deep.
Yeah, and we've got a stack of docs to get through. But the good news is we're going to try to break it down
Yeah.
into those need-to-know bits
Right.
and hopefully have some fun along the way. So BOM mapping, you go online to buy something. Like a laptop, you get to customize
Yeah.
it, right? You pick your processor speed, how much RAM you want, all that. But
Absolutely.
but then, somebody's actually got to build that thing.
Right.
So how do those choices you made online translate into like the actual physical parts that they grab off the shelf to assemble your laptop?
That is the magic of boom mapping.
Okay, so BOM mapping is that like translator, that connection.
Exactly. That's a great way to put it. It's the bridge between uh what you see on the screen when you're configuring your dream product
Right.
and the manufacturing instructions, the list of ingredients that the assembly team needs to actually build it.
Okay, so precision's got to be key here.
Absolutely. Even a small error could mean, the wrong parts, delays, all sorts of headaches.
Yeah, no pressure then.
Yeah.
So these docs mention two main ways to do this mapping thing, table-based rules and then these kind of more advanced BML rules.
Right.
So
Yeah.
what's the difference there? Like when would you use one over the other?
Yeah. So think of table-based rules as your sort of starting point
Right?
for, simpler scenarios. You can picture like a giant spreadsheet,
Oh,
and in one column you have all the configuration choices, and then next to it, the corresponding part numbers. So if you choose laptop, the table knows to include part LP94777. Pretty straightforward.
yeah, I see that. But I'm guessing if you have, thousands of options and combinations, that spreadsheet could get out of control pretty quick.
Absolutely. And that's where BML comes in, business modeling language. It's essentially a way to write little programs, little instructions for much finer control. So instead of that static table, you have dynamic rules. So you could say, if they choose a 15-inch screen and the high-res display, then include this specific screen part number.
Oh, so it's less like looking stuff up in a spreadsheet and more like actually writing the instructions themselves.
Precisely. BML gives you the power to handle much more complex scenarios with conditional logic, calculations. You can even manipulate quantities on the fly.
Okay, sounds powerful. We'll have to dig into that more later. But for now, let's stick with those table-based rules for just a minute.
Sure.
Because those, at least to me right now, seem a little easier to grasp.
Yeah.
Now, the docs mention these things called effective dates and how they relate to BOMs. And I'm all for things being effective.
Right.
But how does that apply to, like, a list of parts?
Right. Well, BOMs, they're not just static lists. Think about promotions, right? Where a certain accessory is included for free, but only for a limited time.
Right.
Effective dates make sure the right BOM, the one with or without the freebie, is used based on when the order's placed.
Ah, so it's like a time machine for your BOM, basically.
Yeah, you could think of it that way.
So you don't accidentally give away free stuff forever.
Yeah.
Okay, so let's go back to that laptop example for a minute.
Sure.
So I'm online configuring. I get to the processor selection. Is that where the BOM like starts getting built piece by piece?
Yeah, you can think of the BOM as having a hierarchy.
Okay.
At the top, you've got that main laptop item, but you wouldn't add a specific processor part until you've got that laptop, that container in place, right?
Okay.
It builds out logically, making sure things get added in the right order.
So if I choose Intel, the Intel part gets added as a child under that main parent laptop item.
That's a great way to visualize it. And the same logic applies as you go deeper.
Oh, interesting.
You choose a processor, then you pick a cooling fan, and the BOM mapping is going to know which fan goes with which processor. It's a cascade.
Okay. Starting to sound like a giant puzzle where every piece only fits in a certain spot.
I like that analogy.
But what happens if you change your mind midway through? Like I pick Intel, then go, wait, no, I want that AMD chip instead.
Well, that's where reconfiguration comes in. That's a key part of what CPQ does.
Okay.
It handles changes gracefully. So you swap those processors, the mapping rules kick in, remove that Intel part, and slot in the right AMD one. It's all about keeping everything consistent.
Okay, good. Don't want to end up with a Frankenstein laptop.
Yeah.
So we've got table-based for the simpler stuff, the BML for when things get, complex.
Yeah.
Anything else in CPQ's toolkit that helps with this whole mapping process?
Well, the document mentions something called single select pick lists.
Okay.
Sounds complicated, but they actually simplify things.
Always a fan of simplicity. How do they work?
You know those drop-down menus you see all the time? Choose your color, select your RAM, those are what they're talking about. Single select pick lists or dynamic menus make it super easy to connect those choices to specific BM changes.
Okay.
You pick from the drop-down, and behind the scenes, the right parts get added or removed. No muss, no fuss.
So streamlining that whole user experience, basically,
Mhm.
making it easy to, like, translate those clicks into physical parts.
Precisely. But there's one more piece to this puzzle that's really powerful, and that's configurable arrays. Now, this is where things get really interesting.
Ooh, I like interesting. Hit me with what are configurable arrays all about?
So picture this. You're configuring software, and you can add optional features, right?
Okay.
Each feature you add creates a new row in this array. Configurable arrays let you map parts to each of those rows dynamically. So for every feature you select, the BM gets updated with the necessary components. You can even control the quantity of each part based on what's in that row. It's incredibly flexible.
Okay, so it's like having a mini BOM for each feature you add on.
Exactly.
That's powerful. And they give an example using application software, right?
Yeah. Imagine selecting features like antivirus, encryption, data backup. Each one gets added to the array, and the BOM mapping just automatically pulls in the correct parts and quantities for each feature.
Okay, now I'm seeing how all these pieces kind of start to fit together. But with all this complexity, things got to go wrong sometimes, right? What if someone typos a part number, forgets a crucial component, human error? Seems like there's a lot of room for things to go sideways.
And that's why CPQ has built-in validation. It's like having a meticulous proofreader for your BOM. It can check if those BOM items actually exist in your inventory, flag conflicts, and enforce rules.
Oh, so it's like that safety net to catch those mistakes before they turn into, like, a factory producing laptops with the wrong motherboards.
Exactly, exactly. So, peace of mind, essentially.
Good, good,
Go.
because that could get messy fast.
Mhm.
Speaking of which, we've been talking a lot about this sales BOM, the one the customer sees on their quote.
Right.
But the doc also mentioned something called a manufacturing BOM.
Right. So that's a key distinction. The sales BOM is the high-level view. It's what the customer's buying. You think of it like ordering a pizza. You see the toppings, the size, the price.
Okay, yeah.
But the manufacturing BOM, that's the detailed recipe. It includes every ingredient, every measurement, every step in the process.
Okay, so it's like the difference between reading the menu and getting the chef's secret cookbook.
Exactly. And BML lets you control what goes into each one.
Okay.
You can specify, what details are relevant for sales and which ones are needed for manufacturing. Everybody gets the info they need without unnecessary clutter.
That makes sense. But we're getting kind of deep in the weeds here. I think it would be cool to see some of this BML magic in action. The doc provides some code snippets. Maybe we can peek under the hood a little bit. No need to get super technical, but I'm just curious to see what the BML stuff actually looks like.
Absolutely. I think that'd be helpful. There's a good example called add a BOM item sample that shows how to create a JSON object for a new part. And JSON's just a way to structure data so computers can understand it.
Okay, so it's not like some arcane ancient language, right? More like a clear set of instructions.
Yeah, exactly. Don't get bogged down in this specific syntax, but just notice how BML uses commands to define things like the part's name, its number, quantity.
Got it. So bridging that gap between, like, human intention and machine execution.
Precisely.
Okay, BML isn't as intimidating as I thought, but we've covered a lot of ground, and there's so much more to unpack about BML, especially how to handle those really complex scenarios. Maybe we take a quick break, come back, and really dive into those nuances.
Sounds like a plan. Plenty more to explore. Back into the BML world. Ready to go.
Oh, absolutely. We were just starting to get into those code examples. I'm really curious, like, what all can you do with this BML language? The add a BOM item was pretty cool, but what other kind of tricks does it have?
So one thing that makes BML really powerful is handling those what-if situations you get in complex configs. Like, the doc mentions using BML to actually delete a BOM item.
Wait, delete. I thought we were all about adding stuff. There are times you got to remove something based on what the customer chooses.
Exactly. Imagine configuring, say, a server. There's an optional upgrade for a fancy cooling system. But if they choose that upgrade, you got to get rid of the standard fan because it's not needed anymore. BML handles that kind of logic.
Okay, so it's more than just adding parts. You can fine-tune the BOM based on all these dependencies.
Yeah.
Like, if this, then that, but if this other thing, then WHOA, something totally different.
You got it. It's that level of control, down to the individual part. And it's not just add or remove. You can tweak existing BOM items, too.
Okay.
Like, adjust quantities based on a choice, or set attributes for a BOM item.
Hold on, attributes. What are BOM item attributes? Why would you mess with those in BML?
Great question. So besides the part number and how many, BOM items can have extra properties or attributes that give more info about the part. Could be color, size, even things like serial numbers or a software license key, all kinds of stuff.
So it's like adding little notes to each part on the list, specifying stuff beyond just what it asks.
Precisely. And BML lets you set these attributes dynamically based on what the customer picks. There's an example in the doc where they use it to set a membership card type based on the customer's loyalty rating.
So like if I'm a super loyal customer, I get the platinum card. But if I'm new, it's the basic one. Makes sense. It's not just the parts, it's any data that goes along with them.
You got it. Personalization all the way down. And talking about dynamic stuff, BML gets even more powerful when you combine it with JSON path functions.
JSON path. Okay, getting a little techie now. Is this where I need my programmer dictionary?
Nah, it's not that bad. Remember, JSON is just that way to structure data so computers get it. JSON path is like a set of tools to move around within that structure, find specific bits of info, like a map for a complex BOM.
Okay, so if I need one tiny detail buried deep, JSON path helps me pinpoint it. Gotcha. But how does that actually work when you're coding?
Well, the doc mentions functions like JSON path get single and JSON path get multiple. They let you pull out specific values from the BOM based on where they are in that JSON structure. So you could grab the part number of a component, even if it's like nested deep down.
Okay, so we've got BML for the logic, JSON path to find the right data, building a custom toolkit for these BOMs, huh? But you mentioned earlier sales BOMs versus manufacturing BOMs. Does BML work the same for both of those?
Good catch. That's where it can get tricky. When you're writing BML rules, they can apply to either one, depending.
Wait, so the same rules could work on both. Doesn't that get confusing? How does it know which BOM it's supposed to be messing with?
That's where careful coding matters. In the BML, there's a field called category that says whether it's for the sales BOM or manufacturing, like a little flag telling it which context it's in.
So you could have one rule that adds like a warranty to the sales BOM, but not the manufacturing one, since that's handled differently when they're building it.
You nailed it. That control is what makes BML so powerful. Tailor-made BOMs for each department. Everybody's got what they need. No clutter.
I'm seeing the appeal, but also realizing how much thought goes into these rules. Not just code, but understanding the whole process, the different BOMs, what can go wrong.
Couldn't agree more. That's why the document's big on testing and validation. Don't just unleash your BML on the world. Make sure it's solid, won't break stuff.
Speaking of breaking stuff, one example was create a root BOM from scratch. It seems wild building a whole BOM just with BML. Is that like real world stuff or just showing off?
It's definitely an advanced move, not everyday stuff. Usually you're working with existing BOMs, making tweaks, but it shows what BML can do. If you needed to, you could skip those table-based rules entirely and just build the whole structure in code.
Ultimate power over the BOM, huh? Create, modify, delete, like a 3D printer for BOMs.
Exactly, but with great power.
Responsibility, right.
Yeah.
And that brings us to idempotency.
Ooh, vocabulary word. Remind me, what's idempotency mean for BML?
Put simply, it means running the same rule multiple times should have the same effect as running it once. Think of an elevator button. Pressing it once sends you to your floor. Pressing it 10 times doesn't send you there 10 times.
Right, just confirms that's where you want to go. So idempotency in BML means if a rule accidentally runs twice, it shouldn't duplicate stuff or mess up the BOM.
You got it. Consistency. Even with hiccups, it's a safety net for your code, especially when things get complex.
This is a real balancing act, huh? You want that customization power, but also got to keep things predictable. Exactly. Understanding those nuances of BML, JSON path, configurable arrays, and those sales versus manufacturing BOMs is key. It's not just coding, it's mastering the whole system.
And it seems like CPQ tries to make it user-friendly, but still powerful for when you need it. But they also mention restrictions to prevent errors, right? Especially with those configurable arrays. What are those all about?
Think of them like guardrails. They keep you from accidentally making invalid BOM mappings. Like there's one that says you can't use a configurable array attribute more than once for the same BOM item mapping.
So you don't accidentally add pepperoni twice to your pizza order. Gotcha.
Yeah.
But what other restrictions are there? Why are they so important?
Well, there are a few different types, each addressing a potential issue. Some ensure certain attributes are always set, some prevent conflicts between different configuration choices, and some enforce specific data formats. It's all about helping you avoid common mistakes, making those BOM mappings super reliable and accurate.
So they're like that little voice in your head saying, are you sure you want to do that? Could cause problems later.
Exactly. Guidance built right into the system so you can navigate all this complexity and end up with configurations that work.
That is reassuring, because with BOMO mapping, any help is appreciated. But we've been BML focused for a while. Maybe we take a step back, see how all this tables, BML, those pick lists, fits into the big CPQ picture.
Great idea. Time to look at the bigger picture, because while the individual pieces matter, it's how they work together that makes the magic happen.
Sounds good. Lead the way. I'm ready to see how this puzzle comes together.
Okay, so I think I'm getting the hang of this whole BOM mapping thing. We've got our different tools, tables, BML scripts, pick lists, and they each handle different levels of complexity. But so far, we've been talking about using BML to change the BOM like during configuration. What about before the customer even starts configuring? Can you use BML to set things up in advance?
You're thinking about the idea from BOM to launch configuration.
Yeah, is that right?
Yeah, and it's a powerful concept. BML basically lets you use an existing BOM to pre-fill stuff in the configurator. Okay, so instead of starting from scratch, the customer sees a configuration that's already partly done, like based on that BOM. When would you use that?
Think about a quote that includes a BOM, and the customer wants to make changes.
Okay.
Instead of starting fresh, they launch the configurator and see their existing choices already there. Streamlines everything.
Yeah, that makes sense. It'd be annoying to start from zero if you just want to tweak a few things.
Yeah.
But how does BML actually do that?
It lets you say which attributes in the configurator should be pre-filled and with what values, all based on data from that BOM. The doc has an example where they override a simple configurable attribute, something about customer ratings and membership card types, if I remember right.
Right, I remember that from earlier. So instead of the rating setting the card type, they're using the card type from the BOM to set the initial rating in the configurator. So like if the BOM says platinum card, the customer rating's already high.
You got it. Reverse engineering the logic to keep everything in sync with that BOM.
Cool. And it's not just simple stuff either, right? BML can handle the complex configurable arrays too.
Yep. In that software example, if the BOM has antivirus and encryption, those features would already be checked when the customer opens it up, makes reconfiguration a breeze.
Man, the things you can do with BML. We've gone from just adding parts to setting attributes, conditional logic, even pre-filling whole configurations. My mind is kind of blown.
Always fun to explore these powerful tools.
Well, listeners, if you're feeling a little overwhelmed, don't worry. The main takeaway is that BOM mapping is essential in CPQ, and Oracle has given us some seriously cool ways to manage it.
Absolutely. Whether you're using those table-based rules, BML, or mixing and matching, it's all about ensuring your configurations reflect what's actually being built.
And that's what makes this so interesting. It's that link between the sales world, what we see online, and the real-world manufacturing happening behind the scenes.
Connecting those dots, building that bridge, using logic and data to create a smooth process.
So next time you're customizing something online, take a second to think about all this BM mapping going on, making sure you get exactly what you want. It's pretty amazing when you think about it.
Couldn't have said it better.
Well, on that note, we'll leave you with a final thought to ponder. We've talked about adding, removing, modifying BM items. But what if you had to create entirely new BM items, like from scratch, on the fly, based on some really complex logic? How would you even approach that using BML? Something to think about as you continue your CPQ journey. Until next time, keep on diving deep.